So when we have three bond pair and no lone pair, one lone pair, then the shape will be pyramidal, you can say, or trigonal pyramidal. And with the bond angle, it's 107 degrees. Question 6. This compound is this question is about aluminum. Its compound. State the shape of molecule of aluminum trichloride. If you check the central atom, only aluminum trichloride is there. State the shape, like with in terms of AlCl3 only. Okay. Actually, it will not be exactly trigonal planar, but in with reference to this diagram, if you want to predict, this is only prediction. So aluminum will form three bond pair and there's no lone pair. So when we have three bond pair and no lone pair, so what should be the prediction? The prediction will be trigonal planar. According to this, it should be trigonal planar. According to AlCl3. Aluminum chloride can exist as a dimer formed from two molecules of aluminum trichloride. Draw a diagram of this. So how we can represent? Aluminum is forming a bond. If you don't draw the bond pair, you can also draw lines. This is one molecule of AlCl3. And there will be another molecule of AlCl3. Now what happened? There will be a dative bond. So dative bond, the lone pair of the chlorine are transferred or shared with aluminum. And lone pair of a chlorine are transferred or shared with aluminum. So you can also draw a dative bond in this manner. That's also fine. No need to make circle. You can also represent a dot and cross diagram. That's also fine. But you should show, like, draw a diagram of this dimer, show the bonding between the molecules. So to represent the bonding between the molecule, we have to draw the lines rather than dot and cross. Is it clear, this one? How to draw a dimer? So if they don't, yes. If they don't specify, dot and cross only. Yes, if they specify, then dot and cross only, it's fine. Then part C. Calculate the maximum mass of aluminum hydroxide precipitate in CY in excess of aluminum trichloride mentioned. No, excess of, so it means, because when a chemical reaction happen or occur, one is a limiting reagent, another one is an excess. So when they said that aluminum trichloride is in excess, it means we use more than enough for a complete reaction. That's it. So sodium hydroxide is a limiting reagent. So we have the concentration and the volume. First, we'll find the moles, which is concentration time volume. So 1.5 multiplied by 150 divided by 1000. This will give us the moles of the sodium hydroxide, because we always use a limiting reagent to calculate the moles of the product. 0.225 moles. Then we use a ratio because we want maximum mass of aluminum hydroxide. So what is the ratio between sodium hydroxide and aluminum hydroxide? The ratio is 3:1 according to the balance equation. So 3 moles give 1. So 0.225. So this will be X cross multiply. So this will be divided by 3, 0.075 mole will get. And then multiply by the molar mass of aluminum hydroxide, because the mass is equals to moles multiplied by the molar mass. So moles are 0.075 and molar mass of aluminum hydroxide Aluminium is 27 plus hydrogen is 1 into 3 plus oxygen is 16 into 3. So when you multiply, you got the mass in gram, that is 5.85. So 5.85 grams of a product we will get, or aluminum hydroxide precipitates. Part C, any doubt? That's actually a part C which I discussed. Part D, any doubt? I mean, how D2 I got 2 marks. Okay. In part D2, explain how melting point, how metallic bonding leads to a property of electrical conductivity and malleability. D1 and D2, okay. Describe the metallic bonding in aluminium. How to score the 3 marks. First thing, you'll mention a metal consist of a lattice of positively charged ions. That is one thing. And there's a strong electrostatic attraction between the positively charged ion and the delocalized electron. That is another second point. And the charge of aluminium ion is +3. That's the third point. Like aluminum electrostatic attraction between the lattice of positively charged ions and the electron. And in this case of aluminium, the charge on the positive ion is +3. And electrical conductivity depends on the electrons, the delocalized electron, and the malleability, because the layers can slide over each other without breaking. So this was a pop quiz. Any questions?